Hey guys, we're just going to have a quick review of exponential functions. I'm going to tell you a little bit about graphing them, how they're different than linear functions, and how to solve them when they're given to you. So I'm going to go through each step individually. I would like for you to take notes in your journal as we go along. Some of this should be a review, some of it may not be. Okay. Alright, so let's start with exponential functions. Let's just think about what the difference is in exponential and linear. Okay, remember, I've already set this up. Let's start with linear. Linear will be written in slope-intercept form, which means y equals mx plus b. Remember, this is your y-intercept, and m is your slope. Okay, and x is your variable, y is your other variable. Okay, so another way to remember is your x is to the first power. So x is going to be by itself. If I were to look at a table for this, I should see that I am gradually increasing at a steady rate. So I'm adding one, adding one, adding one. Your big thing is your range, which is your y's. Look, I'm adding 2. I'm adding 2, I'm adding 2. So I am increasing at a steady rate. That's usually when you can figure out that the rule is going to be linear. Okay, but we're moving on to exponential, which remember is y equals some number to the x power, which is a little bit more tricky, but it is totally doable. Okay. Alright, so we will see in a table that our x's will still increase at a steady rate, usually at plus 1, plus 1, plus 1. However, look at our y's. We subtract 2, and then we subtract 6, and then we subtract 18, I think. So you are increasing at a different rate each time. Okay, so usually that will see exponential. Remember, the next step I can do is graph it to see what it looks like, and then I can figure out my rule from there. But the easiest thing to do is say, okay, I'm moving steadily, so it's linear. I'm moving at a smaller rate than it jumps. That's probably going to be exponential. Okay, so if I were to graph this and figure out my rule, then I would do y equals something to the x power. This one happens to be 3. And then all of this is negative here. Okay. All right. So that is it linear or is it exponential? Okay, which is on the first part of your homework. Okay. Then we go to how do I evaluate if it's an exponential form or function form? All you have to do is plug in the value and then simplify it if you need to. Okay, so you're probably going to get word problems with this, but in a nutshell, just to show you how to do it, you got to pick out that information, which I want you to be able to do on your own. Okay, but how do I do this? Okay, if my equation is the function of 5 times 2 to the x power, when, let's say you do it 3 times. Okay, so my x is 3. So all I have to do is plug that in for x, which would be 3. So 2 to the third power, remember, is the same thing as like 2 times 2 times 2. So this is 4 times 2 is 8. So then we get 5 times 8 equals 40. Remember, if you had variables in that, you would go as far as you can with them, and sometimes you can't simplify that variable out. Okay, so when you are evaluating, all you have to do is plug it in to the equation. Okay, that should be the simple part of things. Okay, graphing it we have already accomplished and we know how to do it. Okay, how I want you to do it is the first thing you need to do for you step people is to make a table. Remember, we've used the values -2, -1, 0, 1, 2. All I do is, there's my x's, let's plug it in for my x to figure out my y. Okay, so 2 to the -2 power, here's where those things come in handy. Okay, 2 to the -2 power is the same thing as moving it to the denominator. So we still have 3 here, times 3. Okay, so leave their 3 there, move 2 to the 2 power here, so you get 3/4. There's where that comes in handy for you. Okay, so the next one, if I had 3 times 2 to the -1, I'll leave my 3 there, 2 to the 1, which equals 3/2, or 1 1/2. Okay, 2 to the 0 power, we know anything to the 0 power is going to give us 1. So 1 times 3 is 3. 3 times 2 to the first power. 2 to the first power give me 2 times 3 is 6. 3 times 2 to the second power. Here's 4 times 3, 12. Okay. Alright, so then I would graph it on my line. So we got some larger numbers and smaller numbers. I will tell you, when you're dealing with exponential, you're probably going to have some fraction stuff going on in the smaller numbers. So if we go over -2 up 3/4, and then -1 is 1 1/2, 0 is 3, which is also my y-intercept, 1 is 6, and then 2/12 is going to be way up here. It should look something like this. Remember, that's what all of our exponential things look like, is a swoop up. Okay, it will probably never go below here unless we have some negative stuff going on. Okay, so does it look right? Yes, it does, so we can move on from there. That's how we graph it. Alright, so it may ask you to solve the one variable equations. Okay, we've been solving systems of equations, the same kind of thing. Okay, your calculator would actually help you on this, and I have given you the steps right here. Okay, alright, so what do I do? So here's my equation we're going to work. 2 to the x equals 1/2 x plus 2. First thing I need to do, separate them out. Function number 1, function number 2. F of x equals 2x, which is the first side. And then our second one, g of x, you could use whatever. It's just giving you, usually you'll see f and g. Okay, so function number 1, function number 2. Second side, we'll go to the other side. Okay, when I am graphing it, okay, if you use your calculator, you're going to graph it using y1 and y2. Then graph it, push graph. Okay, then you use the calc feature, choose intersect to find where the lines intersect. Okay, this is the same thing we did for solving systems of equations. Or if I want to do it by hand, which I love to do, I could make my chart like normal. My x and y, -2, -1, 0, 1, 2 can fit right down there. And I'm going to do 2 of my first thing over here. So 2 to the -2 power, 2 to the -2 would be 1 over 2 squared, which is 1/4. Okay. So this would be 1/2. 2 to the 0 would be 1. 2 to the first would be 2. 2 squared is 4. Okay, then I would take my other one, my other equation, and make a chart for it. Plus 2. Use my same values, -2, -1, 0, 1, 2. If you can see the 2, I'll put 2 over here. Alright, so I plug it in. A half times -2 is -1, plus 2 gives me 1. Half times -1 is -half, plus 2 is 1 1/2. Half times 0 is 0, plus 2 is 2. 1 times a half is a half, plus 2, 2 1/2. And then 2 times a half is 1, plus 2 is 3. Okay. Then what I would do with my chart is I would graph this equation, and then I would graph this equation. Now, you're going to get more precise on the calculator, of course, but let me add some graph paper down here. Okay. All right, so we're going to go -2, and then up to a 4th. Sorry, let's fix this line. It's not exactly on it. Okay, so we will go -2, 1/4, okay, -1, 1/2, 0, 1, 1, 2, 2, 4. So this is what this one would look like. I'm going to change colors just so you see the two different things. Okay, -2, 1, -1, 1.5, 0, 2, 1, 2.5, and 2, 3. Okay, so when I graph this, it should be a clothesline, and you will see that it intersects. So it's wanting to know that if this one continued on, you'd probably see an intersection here as well. Okay, so that is solving one variable equations. Graph it, and all it's wanting to know is what is this point and what is this point. Okay. All right, one more thing for you is, this is on your homework as well. If you're giving the domain, it's going to ask you what is the range. All you have to do, remember your domain is your x's, your range are your y's. Okay, so what I have to do, you can make a chart if you want to organize this for my x's or your domains, same thing. Okay, it's asking me -2, -1, 0, 1, 2. Okay, all you have to do is just like we have been doing, plug it in. Okay, so 5 to the -2. Your easiest way here, remember, is to put 5 on the bottom and then 1/25. You will see I did not get a calculator out at all. Okay, this is equals, not a negative. Okay, so all you have to do is plug in these numbers to your equation to find out what it's going to be. Remember, anything to the 0 power gives us 1. Okay, and this is 1/5. Okay, so what it's wanting to know, it will also ask you as the domain increases. So as this number increases, does the range increase or decrease? That is very simple. Do these numbers go up or do they go down? So you want to know, as we go up, did the number's value increase or does it decrease? And you'll see 1/25, 1/5, 1, 5, 25. They're getting bigger, so they increase. Okay, sometimes they'll get smaller. Then you would say decrease. Okay, all right, so that's what you need to know with exponential functions. We will work on the word problems. Remember, if you are going to take more than 5 to 10 minutes, you need to work on those word problems at home. Remember, your homework is on the paper. You are going to do, let me make sure I have the right numbers. On the front side, make sure you do 1 through 12, and on the back side, make sure you have 17 through 28. Try the word problems. Try the word problems. I'm going to try the word problems on your own. Okay. This part will be a grade. You can count your money on it. Okay. All right. Have a wonderful weekend. I'll see you on Monday.